Now in section 5.4, what we'll look at is actually graphing the inverse of the exponential functions. That means we're looking at graphing the logarithmic functions. So let's take a look. Well, remember the idea behind inverses is that you're swapping x's and y's. So if we look at the original function for this exponential on a, notice that it had a horizontal asymptote here at 0. That was the y equals 0. So what will happen to that in the inverse for the logarithm graph is it will have a instead of y's an x, which would be a vertical asymptote at x equals 0. So it will turn into a vertical asymptote at x equals 0. What also happens is that point 0, 1, we've already talked about this a little bit, will turn into the point 1, 0. And for instance, the point 1, 4 turns into the point, swap around the x and y, 4, 1, so 1, 2, 3, 4, 1. And the other point, negative 1, 1/4 will turn into 1/4, negative 1. And just like before, it will still be increasing. And the original function, look, was a 4 to the x. So it's base 4. So this will be the graph of log base 4 because the base stays the same of x. Notice the domain of this graph is not the same though. The graph doesn't even start until here at 0. So its domain is 0 to infinity. Be careful. There's a parentheses at 0 though because 0 cannot be included in the domain because it's a vertical asymptote. Let's look at problem B. What we were just looking at was the graph of logarithms with a base bigger than 1 because we were looking at exponentials with a base bigger than 1. Now we're going to look at exponentials with a base less than 1, so that means we're going to start looking at logarithms with a base less than 1. Now on B we had an actual an exponential graph that had actually been shifted a little bit. It had been shifted, it looks like down 3, because we had a horizontal asymptote at y equals negative 3. But what that will turn into in the inverse is an x. So that will turn into a vertical asymptote at x equals negative 3. That'll be a vertical asymptote now. Now let's go point by point. Notice that the point 0, negative 2 will flip and turn into the point negative 2, comma 0. The point negative 1 will still be the point negative 1, because if you switch x's and y's, it stays the same. The point 1, comma negative 5 halves. Remember, negative 5 halves is about negative 2.5 if you use a calculator. So that means, switching around the x's and y's, that at negative 2.5 for an x value, the y will be up at 1. So, kind of filling in our graph for our logarithm, it will look something like this. Again, notice, just like the exponential graph, with the base less than 1, it was decreasing. Same thing here, the logarithm graph is decreasing. Notice, though, that its domain starts here at negative 3 and continues on to infinity, but you cannot include negative 3 because it's a vertical asymptote. You will not touch it. So we have to include that as a parentheses, not a bracket. So negative 3 is not included in the domain. So what does this mean as a general rule? It means that logarithms with a base bigger than 1 will be just like before, increasing, except for instead of a horizontal asymptote like we had in the exponential graphs, it's going to be a vertical asymptote that will start at x equals 0. And instead of going through the point 0, 1, we're now going to go through the point 1, 0. So we'll go through the point 1, 0 instead this time. And like I said, if the base is bigger than 1, we will be increasing. If the base is less than 1, though, just like before, we will be decreasing, which means it will look something like this instead. Either way, though, the domain is going to be 0 to infinity. Again, where you cannot include 0 because it is a vertical asymptote. So we'll leave that as a parentheses. However, the range, though, is negative infinity to infinity because it does go up and down forever. So we're not going to do a lot of these graphs, but we're going to do a couple graphs of logarithms. But let's take a look.